Hi, my name's Steve Mann and this is Paper Classroom. Welcome to another science video tutorial. In this particular tutorial we're going to be talking about the nucleus of the atom. So what's there, why is it there, what influence do they have, how do we use it? So it's the nucleus, it's not the electrons on the outside, but it's the nucleus that actually defines and identifies which element it is. The nucleus also controls the mass of the atom. Electrons weigh so little, it's not worth counting. And the nucleus really controls the chemical nature of that particular atom, more specifically the proton in the nucleus. Now, in a previous video, we looked at the evolution of atomic theory, and we looked at, very briefly, at modern atomic theory. I'm going to wind back a little bit to the Niels Bohr model, and that's really good enough for us. We're not here to study, physics at a deep level or chemistry at a deep level. We're here to study papermaking at a deep level and just know enough about chemistry and general science to get us by. So if we use the Bohr model, it makes things a lot easier to understand and makes life a lot simpler. So the nucleus consists of two particles, protons and neutrons. The green circle will represent protons and the blue circle will represent neutrons. Proton, as you can see there, has a mass of 1 unit, 1 atomic mass unit, and it has a charge of +1. Where these units come from is it's an arbitrary unit in a way. If you were measuring a ship, if you were weighing a ship, what units would you use to measure it in? You'd be measuring it in tons. If you were buying some potatoes or some rice from a market, you'd be buying it in kilos. If you were doing some food preparation at home, maybe baking a cake, you'd be weighing in grams. If you were formulating medicines or taking tablets, you'd be talking about milligrams. So you use a weight that's appropriate to what you are weighing. When we get down to the subatomic level, there's nothing to compare it against really. So we took the weight of 1 proton and said, right, that's 1 atomic mass unit. We'll compare everything else to that. When we came to neutrons, we found that it weighed almost exactly the same as a proton, so that's 1 atomic mass unit. And when we came to weigh electrons, it was so small, it's what we might class as negligible. So, when we're studying the nucleus, we need to know that the nucleus is composed of protons and neutrons. A proton weighs 1 unit and it has a charge of +1. A neutron also has a mass of 1 unit and it has no charge, it's electrically neutral. So let's take a look at protons first of all. The protons control the chemical nature of the atom. As the number of protons in the nucleus changes, the chemistry of the atom changes. Therefore, the number of protons identifies which element it is. And I've got a couple of examples for you. Each element we've given a unique number to, and that number is the number of protons. So if there's 1 proton there, irrespective of what else is there, it can only be 1 element. If there's 10 protons, it can only be element number 10. If there's 105 protons, it can only be element 105, irrespective of what else is there. So the protons are the same as the atomic number. So here we have one proton. So my question to you is, what's the atomic number of that atom? 1, correct. And out of interest, the element which has atomic number 1 happens to be hydrogen. Now, interestingly, hydrogen is the only element to have no neutrons, naturally. There are ways of pushing neutrons in there to change its nature, but normally hydrogen has no neutrons. And if you go back to the previous video, we talked about why neutrons were there. We said that if you have two protons, they would want to push each other apart. So there must be something in it there that prevents them pushing each other apart. And that's why people came up with the idea of the neutron. With hydrogen, there's only one proton, there's nothing to push against, so we don't need any neutrons. So hydrogen has an atomic number of 1 for one proton and an atomic mass of 1 because there's only one proton. Okay, I'll ask you the question again now. Here we have a different atom. This is the number of protons in the nucleus. What's the atomic number of this atom? Correct, it's atomic number 2. And anyone know what element atomic number 2 is? It's helium. Good. Another go. So here we have an atom that has 3 protons in its nucleus. What's its atomic weight? Okay, that's right, it's 3. And for those of you that would like to know, the element which is atomic number 3 happens to be lithium. One more now. I could go through all 100 odd elements, but one more just to keep us a bit sharp. Here we have 6 protons in the nucleus. What is the atomic number of that element? Correct, it's 6. And does anyone know what that particular element is? It's carbon. Now we'll use carbon later on to illustrate some other things for us. So let's move on to the neutrons. What do we know about neutrons? They weigh 1 atomic unit and they've no charge. Because they weigh 1 atomic unit, they will contribute to the mass of the atom. But that's all. They don't have any effect on the chemistry. They don't change its atomic number. But what they do is create what we call isotopes. An isotope is an element where it has more than one atomic mass, because there are different numbers of neutrons. And I'll give you an example of this in a moment. Let's start off with hydrogen. Now we move on to helium. Hydrogen, go back a moment. Hydrogen, 1 proton, that's it. It's nothing to push against. It doesn't need any neutrons. Then back to helium. Helium is atomic number 2. That means it has 2 protons. 1 proton, 2 protons. Elements, usually with the exception of hydrogen, all elements have at least as many neutrons as they do protons. Often they have more. So if helium has 2 protons, it will have at least 2 neutrons. And I've just placed them in the middle there just to show you that they're interfering with their repulsive forces. So helium, atomic number 2, because it has 2 protons, atomic mass 4. 1, 2, 3, 4. Okay, let's do that again. with another element. Let's look at lithium. Lithium is atomic number 3. So here we have 3 protons because it's atomic number 3, and it has 3 neutrons. Each of those particles weighs 1 atomic unit, so altogether 1, 2, 3, 4, 5, 6. Atomic mass of 6. And again, carbon. Carbon is atomic number 6. Because it has atomic number 6, it has 6 protons. Because it has 6 protons, it will have at least 6 neutrons. Each of these particles weigh 1 atomic unit, so if we add them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, carbon, 6 protons, atomic number 6, atomic mass units 12. But, what do you think of this? First of all, can you identify what element it is? The blue circles represent protons, the green circles represent neutrons. So, first of all, you work out its atomic number. Its atomic number is the number of protons. 1, 2, 3, 4, 5, 6. So we've just said carbon has 6 protons. Therefore, this atom, the nucleus that we're looking at in this atom, it must be a carbon atom because it has 6 protons. But it has 8 neutrons. So its atomic mass is not 12 like we saw with the previous carbon. It's 14. So how do we differentiate between these atoms? We do it in the way that we write this shorthand down. So this is carbon 12,6 and this is carbon 14,6. What this nomenclature means is C tells you the element, carbon. The 6 there tells you how many protons there are in the atom. As it's carbon, atomic number 6, there must be 6 protons. And the 12 there, the higher number, the higher value number, tells you the atomic mass. So it has 12 units. So if it has 6 protons and its atomic mass is 12, then by subtracting 6 from 12, that tells you how many neutrons there are. There are 6 neutrons. Over here, C is carbon. The 6, how many protons there are. The 14, the total mass of the nucleus, 14 atomic units. If we subtract 6 from 14, we're now left with 8. Therefore, there are 8 neutrons. And there we see 1, 2, 3, 4, 5, 6, 7, 8. So this is the shorthand that we use to describe these different atoms. And when you get the same chemical with different neutrons, we call them isotopes. And the only real difference is the density of the material. These materials are more dense. Now, nature doesn't like to have too many protons, so ultimately it will fire out these protons, and this is the basis of one type of radioactivity. I'm going to leave you with a little puzzle now. Here we have element X. Element X, 9140. What I want you to tell me is how many protons does that element have? How many neutrons does it have? What's the atomic mass of that element? And what's its atomic number? Now I suggest you stop the video at this point, work on those. When you've got your 4 answers, start the video and I'll tell you the solution. 5, 4, 3, 2, 1, here we go. The number of protons is 40. That's this here, the number of protons. The number of neutrons is the total mass minus the number of protons. So 91 minus 40 equals 51. So there are 51 neutrons in that particular nucleus. Its atomic mass is 91. That's the higher value figure. And finally, the atomic number is the number of protons, which is 40. So I hope you enjoyed this particular video. Thank you for watching. Please enjoy our other videos. Please send us feedback. We read all your feedback. And I look forward to seeing and making more videos for you in the future.